Good morning, dear students. So today I'm going to explain about color image processing. So here in the beginning of the class, what I explained, different types of images. One it is called as a binary image. Second one it is called as a gray image. And third one is called as a color image. So during these previous classes, binary image and gray image, their applications and how to represent all these things I was discussed. Now today session I will going to elaborate about the color image, how to process the color image. So all these things I will going to discuss. So in the first slide, now I will look into the why color image processing. Color simplifies object identification and extraction from scene. Scene is nothing but an image. Simplified object identification and extraction from the scene. The particular color should be simplified. The object identification and extraction. And then thousands of color shades can be used with a human eye, whereas only few gray levels shaded are the particular colors to be identified. These colors to be identified in a scene or an object. These color image processing we categorize into two types. One it is called as a full color processing. Second one is called a pseudo color processing. So image acquired with a full color sensor like a color TV, camera or color scanners. The similarly, we another category that is called as pseudo color processing. In this pseudo color processing, assign color to particular monochrome intensity or range of intensities. So in this module, I will going to discuss both full color processing and pseudo color processing. Even as per the syllabus, these two things to be discussed. Now I'll come to the next important concept. It is color fundamentals. So before going to the color fundamentals, that Isaac Newton discovered the one concept that white light when passes through prism, it breaks into the 7 colors, that is called as Vibgaya. while each color smoothly blend into others. The color perceived as a wavelength reflected back from the object. When we are going to consider and any object reflects, these all reflected 7 colors in equal proportion. It looks and it appears white. When an object reflects wavelength corresponding to green colors and observes all other wavelengths, it will appear green. When an object does not reflect at all or it observes all wavelengths, it appears a black. So this is a very basic fundamental concept. The same thing they are going to consider in this color image processing. So here in this diagram, it is called as a color spectrum. So here the white light passing through a prism, then all 7 colors, that is what we called as a waveguides. So that is infrared and ultraviolet colors. This is a very basic things. I hope this all studied from the your school days. Now we can consider the same concept, how electromagnetic spectrum with infrared and UV light with their specific wavelength to represent nanometers. These wavelengths comprising the visible range of electromagnetic spectrum, ultraviolet to the infrared. So in between that ultraviolet and infrared, some visible spectrum. I think in the slide it is visible all these things. So these attributes of monochromatic light, only one attribute, which is intensity. Then color light, we have 3 attributes: radiance, luminance, and brightness. So here we look into that some of the primary and secondary colors. So here when we are going to consider the human eye, there are 6 to 7 million cones in the human eye, which can be divided into 3 categories, mainly red, green and blue, RGB. 65% are sensitive to red, 35% are sensitive to green, 2% is sensitive to blue. Due to these observations characteristics, colors are seen as combinations of 3 primary colors: red, blue and green. So here you can red, blue or green since colors blend with each others. Therefore, for standardization of CIE designated three primary colors, these blue, green, red primary colors had to form secondary colors magenta, cyan and yellow. These are another three secondary colors. So please look into these primary and secondary colors. Very clearly it indicates some different primary and secondary colors of light and pigments. So with the continuation from these, we'll go into characteristics of some of the colors and models we are going to discuss. Now I hope that today's concept only we look into the fundamental concepts of color images. So with the continuation from the next, we're going to concentrate some more models step by step. So now shall we wind up this today's class and continue in the next class. Thank you.